All right. For this video lesson, we're going to be working on multiplying radicals. Just a lesson overview here. So we will start with reviewing polynomial multiplication using the FOIL method. So that is the first outside, inside, last. Then we will move on to radical multiplication. And lastly, we will solve some problems related to geometry using radicals. Okay, so jumping back to polynomial and multiplying brackets here. So if we have 2x times 3x, we're just going to multiply the coefficients out front, and then we're going to multiply or add the variables which are attached to those coefficients, okay? So we're gonna have 3 times 2 times x, and this will give us 3 times 2 is 6, and x times x is x squared. So that will give us 6x squared. Okay, so even when we have two different variables, we can just multiply the coefficients out front and then group the different variables together after, okay? So here we will have 5 times 3 times x times y, and that will give us 15xy. Okay, when we have two terms in one bracket and one term in the other, we just need to distribute that one bracket to each of the terms in the second bracket. So 2a multiplied by a gives us 2a squared, and then 2a multiplied by -3 gives us -6a. Okay, so it doesn't really matter what our variable is when we're multiplying. We'll just multiply the coefficients out front, and then we will multiply the variables as well, okay? And that's going to be very similar to when we are working with radicals again, okay? So just a couple more examples here. Here when we have two terms in each bracket, this is where we have our FOIL method. So I'm going to take my first term in the first bracket, multiply it by the first term in the second bracket. So that will give me a squared. Then I will multiply that by the second term in the second bracket, giving me -a. Then I will do the same thing with the second term in the first bracket. So that will give me positive 4a minus 4. Now, to combine like terms, the exponents must be the same on our variables, okay? So for a squared, it is the only a squared term, so we're going to leave that one alone. For a to the 1, we have a -a and a positive 4a, so that will give us positive 3a, and we only have one constant, which is our 4 there. Okay, so that is our fully simplified answer. Okay, and we'll do the same thing here with the second bracket. Note that we do have x and y variables, and that is okay. When we are multiplying, we can just go straight across. Okay, so we'll use our FOIL method there. So we get 2x multiplied by x is 2x squared. 2x multiplied by -4 gives me -8xy. 3y times x gives me positive 3xy. I'm just going to write those in the same order. It's going to just allow me to identify our like terms a little bit better. Okay, and then lastly, we have 3y multiplied by -4y, giving me -12y squared. Okay, again, we need to fully simplify our answer. We have an x squared term and a y squared term. We will leave those alone. But we have -8xy and a positive 3xy. So we will simplify those. We get 2x squared. -8 plus 3 is -5xy minus 12y squared. Okay, and we've kind of hinted at this question, or the answer to this question. Do we need the same variables in order to multiply the terms? No, we do not. You can multiply any term by any term. So do you think you will need the same number under the radical, so our radicand, to multiply those terms? No, we do not, okay? And we will get into some examples in a bit. I just wanted to make one more note. Do we need the same variables in order to multiply? No. However, for adding and subtracting, when we are dealing with variables, it needs to be the same variable. So we cannot add like a 3x to a 2x squared, right? We would need it to both be like 3x plus 3x, right? And that's going to be the same thing with radicals, okay? If we are simplifying our radicals, we need to make sure that our radicands have the same value when we are adding or subtracting, okay? Adding or subtracting. You need to have the same degree of exponent on your variable and the same variable, right? You can't add a 3x to a 4xy. And if it's 4 radicands, same 4 radicands. All right, so let's get into some radical multiplication. Okay, so we have root 5 multiplied by root 2. So is what we're going to do here. We're just going to multiply the radicands together. Okay, so 5 times 2 gives us root 10. And we could try to simplify that, but that would just simplify to root 2 times 5, right? And there's nothing we can do about that. So root 10 is our fully simplified answer, okay? You could leave it in root 2 multiplied by 5, but that is not proper notation, okay? So root 10 looks a little bit cleaner for us. Okay, so now we have 4 to the square, or 4 multiplied by root 3 and squared. So that looks like 4 root 3 multiplied by itself, right? It's a square. Anything is squared, we're just going to multiply that by itself. So when we're multiplying radicals like this, or a mixed radical, when we have a number out front and a radicand, we're just going to multiply the number out front, and then we will multiply the radical, or the radicand, sorry. So 4 times 4 times root 3 times root 3. So 4 times 4 is 16. Root 3 times root 3 is root 9. And root 9 can be simplified to 3, which is equal to 48. And obviously that's a fully simplified answer there. Okay. For this last one here, we have variables as our radicand instead of numbers, and that's okay. We'll just treat it like we were for polynomial multiplication. Okay, so we have 8 root a multiplied by 9 root a. So we will just multiply the numbers out front, and we will multiply the radicands together as well. So 8 times 9 times root a times root a. Okay, so that will give us 72 root a squared. When you take the square root of something that is squared, you'll just get the value of that number or variable. So our final answer there will be 72a. Okay. So again, just going to multiply the numbers out front and the radicands. And we haven't seen any we've seen a little bit of simplification right here, right? We simplified that root 9 to a 3, so a little bit of simplification there, but we will get into a little bit more simplifying in our next examples. Okay, so we have root 7 being multiplied by root 3 plus root 2. So we need to distribute that root 7 into our brackets. Okay, so that will give us root 7 times root 3 plus, right, we have that plus sign in there, plus root 7 times root 2. Okay, so that will give us root 21 plus root 14. And we can't really simplify that any further, right? We need to have the same radicand to simplify that. So this is in fully simplified terms right here. Okay. This next one is going to be a little bit more tricky. I would encourage you to pause it and try it on your own. Okay. I will go ahead and solve it though. Okay, so same thing. We have a negative 3 root 6 outside of the brackets to be distributed to 2 root 3 minus root 2. So again, we will just multiply that in one term at a time. So that will give us negative 3 root 6 multiplied by 2 root 3 minus negative 3 root 6. I'm going to put a bracket there just to just being careful with my negatives there. Okay, so negative 3 root 6, and that is going to be multiplied by root 2. Okay, negative 3 root 6 multiplied by 2 root 3 minus, and that is okay. So now we will multiply the numbers in front of our radicands, and we will multiply radicands as well. Okay, so negative 3 times 2 is negative 6, and root 6 multiplied by root 3 is root 18. So negative 3 root 2 will give me, so negative root 12. Now I will put that negative in there. Turns into a plus 3 root 12. Okay, at this point, I know that we need to simplify because 18 can be broken down into at least something more simple, right? Same with 12. So let's do that. So we'll have 18. So to get there, we have 2 times 9. And to get to 9, we have 3 times 3. Okay, so we have a pair there. So negative 6. Root 18 becomes 2 times 3 times 3. And then I will do the same thing for 12. We get 2 and 6 and 2 and 3. Okay, remember when we are simplifying here, we're looking for pairs when we are taking the square root of something. Okay, so I have a pair of 3s here, and I have a pair of 2s out front. So I'm going to take those pair of 3s up front and multiply it by the negative 6. So that will become negative 18 root 2. And same thing for my root 12. I'm taking out the 2, so that will become 3 times 2 is plus 6 root 3. Okay, and that is as fully simplified as we can get this term because, again, we need our radicand to have the same value to further simplify. Okay. So note that we have 2 terms in the first bracket and 2 terms in the second bracket. So we will use FOIL here. So 7 times 4 is equal to 28 plus 7 root 6. And then for my second term, I will have negative 4 root 6 and negative root 6 plus positive, or negative root 6 multiplied by positive root 6 will give me negative root 36. And that we can simplify. Okay, we have a little bit of simplifying to do here. Okay, so I notice right away that I have 2 root 6s, so we can simplify that. Root, or 36 is a perfect square, so we can take the square root of that. And then we have a constant value of 28. So we'll leave that alone for the meantime, okay? So this will give us 28. 7 root 6 minus 4 root 6 gives us positive 3 root 6. And the square root of 36 is 6. And we have a negative in front, so negative 6. Now we have 2 more like terms, 28 minus 6. So now we can subtract that. So that will give us 22 plus 3 root 6 as our final answer. All right, so I would pause you to, or I would encourage you to pause this video and try to solve this on your own. Okay, so I'm gonna go ahead and solve this. So we have a rectangle here and we're asked to find the area. So area of a rectangle is equal to the length times the width. Okay, we will call 5 plus 2 root 3 our length, and root 27 can be our width. Okay, so if our length is 5 plus 2 root 3 and our width is equal to root 27, we're asked to find the area. So now we can, because our formula is already written in terms of A, we can just put our values into that formula and solve for A. Okay. So area is equal to length, which is 5 plus 2 root 3, multiplied by the width, which is root 27. Okay, so we will distribute that root 27. I know I set it up a little backwards, but that's okay. We'll distribute that root 27 into the other bracket. So that will give us 5 root 27 plus 2 root 3 multiplied by 27. And 3 times 27 is 81. Okay, so hopefully you're recognizing that we do not have the same radicand, okay, but we can simplify this a little bit to get a better answer, to get the most simplified answer, okay? Hopefully you are recognizing that 81 is a perfect square. So we can take the square root of 81, that will give us 9. And we can simplify 27 into more simple terms, okay? So 27 will be the product of 3 times 9. And to get to 9, it is 3 times 3. So root 27 becomes 3 times 3 times 3. I see a pair of 3's, which I will take outside. So 5 times 3 is 15 root 3, plus 2 times 9 is 18. Okay, so that is the area of this rectangle. And if 15 root 3 plus 18 doesn't mean much to you, if you punch that into your calculator, that will give us an approximate value of 43.98 units squared, right? Area is in 2 dimensions, so it's squared. But again, when we calculate 15 root 3, that gives us an approximate answer. 15 root 3 plus 18, that will give us an exact answer, okay? All right. So let's move on to our last